Okay, this is probably going to be the worst video that you have been given as far as the technology goes. But I am going to go through the analysis questions for the Rebound Height Lab so that you can make sure that you understand. And I will explain, which questions I'm going over. Right here, you'll be able to see what you should skip to in the video. Let's go. All right. So I'm going to speak loudly so you can hear me in the video. What you have over here, we're on page 42 in your notebook, so hopefully you have this open. I'm going to go ahead and just pretend like I took my data and I found my pattern. And the pattern that I found is called proportional, which I know because I took those lesson 4 notes, and so I can identify these relationships based off of the fact that it's a straight diagonal line. That gave me that information from lesson 4 and 5. The C-value that I found in my fake data, and I'm going to choose a C-value that I think is higher than any of the C-values that you found. So I'm going to go ahead and say that I found a C-value of 0.8. And the equation then that I found from Desmos, I'm assuming that you have already done this, is B equals my C value, 0.8 times D, where B equals bounce height and D equals drop height. Okay, I have to have this information in here so that I can do the analysis. If I don't have that, the analysis isn't going to make much sense to me. It's not going to be very useful. So let's go ahead, and the analysis is to compare my data to the baseball's data. So my bounce height equaled 0.8 times drop height. All right. I didn't ask you to do this, but it would be really helpful to you in seeing them side by side, and it's what the mastery check is going to be asking you to do, is to be able to look at a graph where you have 2 lines on the same graph. So I'm going to go ahead and, in a different color, I'm going to draw in the line for my bounce height. Now, I know that if the drop height were equal to 1, then I would have 0.8 times 1. So I'm going to go ahead and go with the 1, put a little dot there, and then I'm just going to go ahead and kind of roughly, I'd like it to go through 0.8. There we go. Draw my straight line. This one is my ball. And this one is the baseball. Okay. It's going to help me out for being able to do these questions. So questions 1 and 2. Compared to your data, what is different about the graph and the equation for the baseball bounce? Well, the graph, the line is lower. And on the graph. And for the equation, I see that it looks really similar, but my number is 0.8, theirs is 0.3. So C value is smaller. I hope you can hear me. We'll see. Compared to your ball, what is different about the behavior of the baseball? Well, let's just pretend like I had the golf ball and here's the baseball. If I drop these on the ground, you didn't even see the baseball even come up because it didn't even make it into the camera. The golf ball was bouncier. So the baseball is less bouncy. Okay, that's what I'm looking for. Question 3 and 4, this is the math stuff, and this is, you really got to know this for the mastery check. You got to know it for the mastery check. So use the graph or the equation to predict how high each ball will bounce when dropped from 0.5 meters. Okay, I'd like to show you both methods because on the mastery check, there's a question where it asks you to predict for a value that you can't get to on the graph. It's like off over here, right? So you can't get there. So you need to know how to do both for this. So let's go ahead. I'm just going to do it for the baseball, and then you can do it for your own ball. All right, so for the baseball, there's 2 methods. The graph method. Okay, so with the graph, what I'm going to do, I'm going to erase this. My drop height is 0.5. D equals 0.5. So I'm going to go find drop height of 0.5 on the graph up there. And I see that when it's 0.5, I can follow that up to the line. I put a little dot there. I hope this shows up. Okay. And then I'm going to move horizontally over to the y-axis. And this will tell me, and now I have to kind of estimate what the bounce height is. Okay, so it's between 0 and 0.2. Looks like it's a little over halfway. So I'm going to estimate and say it's at about point, here would be 0.1, so maybe 0.12. So 0.12 meters. Ooh. Wonderful. Let me pause the video and I'll come right back to that. Okay, great, sweet. Okay, so that was my estimation. The way that you would show your work on the mastery check is I'd be able to see your work on the graph. So there's a more exact way to find it, and that is using the equation. Here's my equation. So bounce equals 0.3 times drop height. Okay? I can then plug in the value that I'm told that the ball has been dropped from. So B equals 0.3 times 0.5. And I'd get out my calculator or I'd do the mental math and I'd go, okay, 0.3 times 0.5 equals 0.15 meters. So see how using the graph, I got close to that, but it was kind of inexact. I was sort of estimating. Using the equation, I'm really following exactly what that line says. You need to be able to do both. Okay, so that should help you out with being able to do the same thing for your ball and then changing it to what if it went to 1 meter. Okay, you should be able to use all those methods. Let me pause and then I'll go on to the back. Okay, so question 5 is asking us, how does the C value affect the graph and what does it tell us about the behavior of the ball? So I drew a little doodle of the graph on there. We've got, the drop height compared to the bounce height. And then we have the baseball over here. I'll make that, baseball. And this one was my ball, MB. Okay, so the bigger the C value, this one had a C value of 0.3, and this one had a C value, I should do it in red, C value of 0.8. Bigger the C value, the steeper the line, right? And there's other words that you could put in there, but the steeper the slope of the line, the higher the slope. I've heard people putting it in different ways. Steeper. Okay, the steeper the slope of the line. So the C value or slope tells us what is it about the ball that we are learning based off of the C value. Now it's actually easier to start with this one. If there is a big C value, then what does that tell us about the ball itself? Well, let me go ahead and here are these two again, right? This one has the bigger C value. I'm pretending like that one was the golf ball, but this one has the big C value. This one has a smaller C value. What's different about their behavior? Let me go ahead and do that again. You hopefully should know this, right? Here we go. Let me see. Okay, hopefully you got that. The bigger the C value means the ball is more bouncy. So if C value is telling us kind of how big C value equals big, how bouncy it is, big, a lot of bouncy, I'm losing my mind here, then the C value or the slope is telling us how bouncy the ball is. And in a single word, the bounciness. We're really serious here in science class. Okay, the bounciness of the ball. So you can tell that property about the ball based off of that C value. So now that we have a word for the C value or the slope, we can write a general equation for the rule for any ball. The bounce height is equal to, instead of C, we're going to write out the word that we came up with times our D. So bounciness times, and then this one was drop height. All right. I don't want to write out the next one. You can write it out in your notebook. But why does it make sense that this equation models the relationship between drop height and the resulting bounce? Well, the bounce height is equal to the bounciness times drop height. So if we have a not bouncy ball, we're going to have a really small number for bounciness. And that would mean that when we drop it from any height, we're not going to get very much of a bounce. I don't know. You can put that into your own words there. But the bouncier the ball, the bigger this number, the higher it will bounce based off of any drop height. I hope that helps.